Hello everyone, I am going to explain question second from exercise 7.6. In this question, we have to prove Rolle's theorem for following functions. So in this video, we are going to solve part A and part B of question second. We will start with part A. In this, the given function fx is x square plus 5x plus 6 where x belongs in closed interval minus 3 to minus 2. So we have to prove the Rolle's theorem. So before solving the question, I want to explain Rolle's theorem. Actually, the Rolle's theorem have three conditions. First condition, the function should be continuous in given closed interval. Second condition is function should be differentiable in open interval. Third condition is the function's value at the lower limit should equal with the function's value at the upper limit of given class interval. If these three conditions are satisfying, if any function is satisfying these three conditions of Rolle's theorem, then there must exist a point between the open interval which is mentioned in the given question where f dash c is equal to 0. So we will start first whether this function is satisfying the three conditions or not. If it is satisfying, then we will move to the f dash c equal to 0. So here the given function is a polynomial function, and we all know that polynomial function is always continuous as well as the differentiable. That's why first we will write down, as we know that a polynomial function is continuous as well as differentiable for every real number, which implies, now these are the first and second condition. First condition is fx is continuous in closed interval. Second condition is fx is differentiable in open interval. Now two conditions satisfied. Now we'll move to the third condition. Third condition is function's value at the lower limit, that is the lower limit is minus 3. So wherever x is there, we'll substitute minus 3 and we'll solve. When we'll solve, we found function's value at lower limit is 0, and now we'll move to the function's value at the upper limit is minus 2. So when instead of x in given polynomial, substitute minus 2 and solve, that will give you again 0. So what we obtain, that the function's value at lower limit is 0 and function's value at upper limit is also 0, which implies f minus 3 is equal to f minus 2. So all three conditions satisfied. So we'll write down, so all three conditions of Rolle's theorem is satisfied. Now we'll move to the f dash c. Before that, just write down the given polynomial, differentiate it with respect to x. So f dash x means it is first derivative. First derivative means we have differentiated the function with respect to x. That gave us f dash x, that is 2x plus 5. We had used the chain rule here, and now not chain rule, we had used the formula x to the power n, that is n x n minus 1, and it's a constant, so its differentiation is 0. 5 is a coefficient, so 5 came here, and differentiation of x is 1, so 5 into 1 is 5. Now f dash x we calculated. Now since all three conditions of Rolle's theorem satisfied, so from Rolle's theorem we have f dash c equal to 0. So f dash c equal to 0. So instead of f dash x, wherever x is there, we'll write down c. So that gives us 2c plus 5 equal to 0. Now this information we obtained from equation 1. Now from here we are going to calculate c. So just shift minus 5 in this side, then 2 is in multiply, it will go in divide. So we obtain c is equal to minus 2.5. Now we have to check this value of c is belonging in the open interval or not. So minus 2.5 of course belongs in the open interval minus 3 to minus 2. That's why Rolle's theorem is satisfied for the given function. Now we move to the B part of question number second. In B part, again we have to prove the Rolle's theorem for given function. Here the given function is e minus x sin x, where x belongs in closed interval 0 to pi. And here students, this fx is the product of exponential function and sine function. Now before doing this question, it is also, we should know that exponential function as well as sine function is always continuous for all real number as well as differentiable for all the real number. That's why these knowledge is very necessary before doing these kind of questions. So as we know that exponential function and here and will come, and sin theta function are continuous as well as differentiable for every real number. So the product, because separately they are continuous as well as differentiable, so whatever be the product of these two, that function is also going to be continuous as well as differentiable. So we are going to write down, so product is also continuous as well as differentiable for each real number. Now after mentioning all this information, now we are going to conclude the Rolle's theorem's first and second condition. The Rolle's theorem first condition is fx is continuous in the closed interval and fx is differentiable in the open interval. Now we will move to the third condition. Third condition is function's value at lower limit and upper limit. So first we wrote here fx. Now lower limit is 0 and upper limit is pi. So lower limit means instead of x we have to write down 0. So when we wrote here 0, and we are going to get 0 because sin 0 is 0. So 0 multiplied by any number, it is going to be 1, is going to be 0. In the same way, we will calculate function's value at upper limit, that is pi. Again we know that sin pi is 0. That's why 0 multiplied by any number is 0. So what we obtain, function's value at lower limit and function's value at upper limit both are equal, that is 0, which implies f0 is equal to f pi. Now since all three conditions satisfied, so just write down here first. Then we will conclude, since all three conditions of Rolle's theorem satisfied, so Rolle's theorem says that there must exist point C belongs in the open interval 0 to pi such that f dash c equal to 0. This is the conclusion of the Rolle's theorem. First we have the three conditions that we have to prove that it is satisfying, and if any function is satisfying the three conditions, then this conclusion we have to do. So here what the conclusion of Rolle's theorem is, f dash c equal to 0. So we need f dash c and we have to keep it equal to 0. So for that, first we write here fx, what is fx, then we are going to differentiate. So first I wrote here what is fx, that is e minus x sin x, and then we will differentiate it with respect to x. First derivative will calculate. So for that we are going to use u dot v. U means first function, v means second function. So first I differentiated e minus x, and we know that e minus x differentiation is e minus x, and because of chain rule we will differentiate this minus x again, that will give us the minus sign. That's why e minus x differentiation is minus e to the power minus x, and sin x I kept as it is, and in second term I kept e to the power minus x as it is and differentiated the sin x. So sin x differentiation is cos x. So to differentiate it, what formula we use? U dot v. This first I differentiated e to the power minus x and then I differentiated sin x. Now here since we need f dash c, so instead of x just write down c. So that gave us f dash c. Now since we are assuming that f dash c equal to 0, so if f dash c is 0, in that situation if left side is 0, then right side is also going to be 0. Now from here take e to the power minus c common and just shift towards right hand side, so it's going to be 0, and then shift this minus I sin c in other side, so it's going to be positive sin c. Divide this complete equation by cos c, that will give you here 1, and sin c upon cos c is tan c. Now from the tan c equal to 1, so at which value tan is 1, that is pi by 4. That's why on comparing both the side we obtain c is equal to pi by 4, and students we know that pi upon 4 is belongs to the open interval 0 to pi. So Rolle's theorem is satisfied, that we obtained a point between the 0 and pi where f dash c is 0. Hence Rolle's theorem is applicable for given fx. So students, we had solved question number second, A and B part. In both the parts we had proved that Rolle's theorems are satisfying for the given function, and Before doing the Ross theorem should be very clear to you. Ross theorem have three conditions: that the function should be continuous in the closed interval, function should be differentiable in the open interval, and upper limit and lower limit should be same. No, function's value at upper limit and function's value at lower limit should be same. Then there exists a point between the open interval where f dash c equal to 0. So by keeping these points in your mind, easily you can solve the questions. Thank you.